All right, so stats, I want to take you through the question that we did yesterday in class that dealt with confidence intervals and dealing with population proportions, okay? One of the things that I want you to realize is the process in terms of conditions stay the same as they were when we were dealing with sample proportion probability questions. We have to have an SRS, we have to have a population that's at least 10 times the sample that we take, and n times p has to be greater than 10, and n times 1 minus p has to be greater than 10. Once again, the population being large allows us to use this standard deviation formula, and the n times p and n times 1 minus p being greater than 10, that allows us to say and assume that the distribution's normal. So this is very important for us to state as part of the process. The formula that's used, and I want to show you where this formula comes from. The formula comes from basically the formula sheet. The formula sheet you're going to get on an AP test is, this is on the second page, I guess, of it. It's under inferential statistics. This is your z-score formula, okay? It's your test statistic, the estimate minus the parameter over the standard deviation. That's how you come up with the z-score. Here's your confidence interval. Spells it out for you. The estimate is going to be the statistic you get from your sample. The critical value is going to be the z-star score or the t-star score. Right now we're working on z-star. And the standard deviation from the statistic, from that estimate. All right? And if you look, they even show you, when we're taking single samples, they even give you the formula for the standard deviation if we're dealing with a sample mean question, or the standard deviation when we're dealing with a sample proportion question. All right? This is the same standard deviation if it's a confidence interval dealing with sample mean, and this is the same standard deviation if it's a confidence interval dealing with sample proportion. Okay? So just know that. It's on there. This will be given to you on tests and things like that. Okay. So interpreting that formula so it fits what we're looking for, our estimate is p hat. That's going to be our sample proportion. Anytime we're using a sample proportion, it's always going to be a z-star score. This is going to be found on table C. Above the confidence level, whatever that's given in the problem, and it's going to be on the same line as the infinity number. And I'll show you that when we go to do it. The difference now is the standard deviation that we're going to use. It's not going to be the sample, it's not going to be the population proportion, it's going to be our sample proportion. That's why you see p hat in here. It's the only difference. When we were doing sample proportion questions before, we were using the population proportion. Now we're using the sample proportion. All right, so this is the question we went over in class. I'm going to go over it again with you right now. We're going to go through all of it. Random sample of 100 high school seniors in a particular city is taken, and it is found that 15% of the students favor a ban on prayer in public schools. So this 15% isn't from the population, it's from my sample. And what I'm looking to do is I'm looking to make some type of conclusion about my population given what I found out in my sample. They're asking me to construct a 95% confidence interval for the true proportion. This is the population proportion. That's the parameter we're trying to make conclusions about, of all seniors in a particular city who favor a ban on prayer in public schools. So I want to find an interval that I can guarantee 95%, with 95% confidence, that the true proportion is going to be in that interval. All right. To be able to find it, I have to start the problem off with my conditions. So the conditions for a sample proportion are the conditions I have up top, and the first one is going to be that the problem states it's an SRS, and this is stated in the question. Number two, we have to deal with the fact that the population needs to be 10 times the sample, at least 10 times the sample. Well, just remember, the sample we picked was 100 high school seniors in a city. So we could assume there is more than 1,000 seniors in that city. And that's not an overreach. When you're talking about a city, you're talking about seniors, you can have more than 1,000, and we sampled 100. So we're good. All right, and because this is good, we can use that standard deviation formula, square root p hat times 1 minus p hat in this case over n. And again, I can calculate that, so I'm going to do that now. Our p hat value is 0.15. 1 minus that value is 0.85. And our n is going to be over 100. When you do that calculation and you actually finish and take the square root, we get a standard deviation of 0.0357. And that's where we are so far right now. Oops, I need to show you that. So there it is. That's going to be the standard deviation that we're going to be using for the question. All right, and then number three is that normal test. N times p needs to be greater than 10, and n times 1 minus p needs to be greater than 10. While our n is 100, our p is 0.15. That needs to be greater than 10. Over here, n's 100, our p is going to be 0.85, and that needs to be greater than 10. So here we're going to have 15 needs to be greater than 10, and over here we need 85 needs to be greater than 10. So we're good. So now we can say that the distribution is normal. And we're ready to go. All right, so I'm going to come back up here, and I'm going to do the question. So the formula for the confidence interval starts off with, now being very specific, it's a 95% confidence interval, and that's going to equal, according to the formula sheet, here's the confidence interval, it's going to be the estimate. Well, the estimate from the problem is the p hat value, 0.15. Then we come to the plus and minus. The next thing is the critical value. Well, the critical value is the value we're going to find on that table C. Okay, it's going to be the value we're going to find on that table C. We're going to go down to the bottom where it says confidence level C. Our confidence level is 95%. And so we go up to the infinity line. That's the line I have in yellow here. And we pull that number, 1.96. That's going to be our Z star score. Okay, that's our critical value. Times, going back to the formula that you'll see on the test, the standard deviation of the estimate. Well, we want the standard deviation of a sample proportion. That's what our estimate is. So the standard deviation for a sample proportion we have down here, 0.0357. So I go ahead and I do this, and I'm going to get 0.15 plus or minus. I'm going to multiply that by through, and I'm going to get 0.06997. And when I go ahead and add and subtract, I get the interval of 0.08003. And when I add that number, I get 0.21997. And that's going to be the confidence interval that we need to attain.